So I absolutely hate organic chemists for doing this, and unfortunately I have to teach it because I'm teaching organic. So we're going to learn the parlance, but I'm going to go ahead and have my little soapbox here. Hybridization is not real. We teach it because organic chemists tell us to teach it. So what is hybridization? Well, if we want to describe the shape of the electron density around an atom that it uses to form its first bond to a neighbor atom, the hybridization gives us this approach. So I have previous videos on where hybridization comes from and how it works, so you probably need to check those out. My issue here is that we're going to take hybridization and we're going to use it synonymously with geometry. And this is kind of a misleading thing because the hybridizations of carbon, nitrogen, oxygen don't give you the same names for the molecular geometries. And again, we're going to focus on molecular geometries and electronic geometries. So, carbon, sp3. How do we make carbon sp3 hybridized? Well, example of this is something like methane, CH4. Carbon has 4 bonds around it, 1 to each hydrogen. We're going to use sp3 hybridized carbons to be synonymous with tetrahedral. sp2 is something like half of ethylene. So carbon has 3 atoms around it and 1 double bond, 1 pi bond, in this case double bond associated with it. And we're going to use this synonymously with trigonal planar. sp hybridized carbon has 2 atoms around, so this is something like half of acetylene. And this will be used synonymously with a linear molecule. So when we talk about sp3 hybridized carbons, we are always referring to carbon that has a tetrahedral molecular geometry around it. sp2 hybridized carbons have a double bond associated with it. sp hybridized, typically it's a carbon with a triple bond bonded to another atom. Now nitrogen. Nitrogen is going to have 3 bonds around it and it's going to have 1 lone pair. So one of our hybridized orbitals here is going to be holding the lone pair electrons of nitrogen. So an example of an sp3 hybridized nitrogen is ammonia NH3. Now the molecular geometry associated with this is trigonal pyramidal. See how I said this is a little confusing? So sp3 hybridized nitrogen is trigonal pyramidal. sp2, this is going to be nitrogen sharing a double bond with a neighboring atom. So in this case, something like a carbon-nitrogen double bond. Or if we look at something like into H2, something like that. In this case, the molecular geometry here is bent. Now for nitrogen sp hybridized, this is something like cyanide, CN, carbon with a nitrogen with a triple bond. We don't have a name for this. Some people will classify it as linear, but this is kind of misleading because there's nothing around it. Molecular geometry is supposed to talk about the atoms relative to the central atom. How about oxygen? Oxygen has 2 lone pairs. And so an example of your sp3 hybridized oxygen is oxygen water. Now this is going to be bent. In the case of your sp2 hybridized, we have 1 double bond. That's it. We have a double bond to this. Is something like a ketone or an aldehyde. There's no name for this. Some people may call this linear, and there's no examples of this, at least within the organic context for sp hybridized. So when we talk about hybridization, we are talking about the shapes of the sigma bonds between these atoms and their neighboring atoms, but we're also going to use it synonymously with the geometry. So an sp3, again, an sp3 hybridized carbon is tetrahedral, sp2 is trigonal planar, sp is going to be linear. These may also show up as well, so if you hear about sp3 hybridized nitrogen, it's really trigonal pyramidal, it's not tetrahedral. And so this is what we mean when we say an sp3 hybridized carbon. We're really trying to get at its molecular geometries.